Hello everyone, my name is Chang Sun and welcome to Women Data Science 2022 Maastricht Conference video series. On March 8, 2022, thousands of participants gathered around the globe for the Women Data Science Worldwide Conference. In this video, Dr. Mirela Popa, an assistant professor at Maastricht University, introduces Dr. Calina Ciuhu-Pijlman at WIS Maastricht Conference 2022. Calina talked about the topic of human-centric data-driven innovation. If you are interested in this topic, please keep watching.
She started her journey in Romania at the Babes-Bolyai University, did a PhD in theoretical physics at Vrije University Amsterdam, and then she was joining Philips Research, doing a lot of interesting projects. And I'm not going to say more, but we are really looking forward to see your presentation on human-centric data-driven innovation. So, Calina, the floor is yours.
Yes, thank you, Mirela. So good afternoon to everybody. And I would like to start with giving a big thank you to the organization. I feel very good to have the opportunity to present some of my data today. And also, I'm under the, impression of very good presentations that were given today, wonderful work and brilliant ideas from the other presenters. I'm Calina Ciuhu, and I'm a senior scientist at Philips Research Laboratory in Eindhoven. And today I would like to present to you work that we do to improve healthcare. And the presentation of today concerns using human-centric data-driven for innovation in healthcare. So I hope that by the end of the presentation, I will convince you that this way is actually important in tackling data problems. I will start with giving a small introduction into the vision of Philips, my employer, and how we want to bring value and save patient lives using artificial intelligence solutions. Well, the work that I have chosen to present today to you is heavily based on what we call parametric body model. So I will also take some time to give an explanation on that. And finally, I will conclude my presentation with some time for questions. And if we have time, also share a few thoughts from my personal drive into the data science. All right, so looking at the trends in our society today, on one hand, we see that population is aging, and together with this, there are an increase in chronic disease, as well as patients with not just one, but with multiple pathologies or comorbidities. Unfortunately, also what we have seen in the last years of the pandemic is that the burden and the shortage on the caregivers is also taking up, and this is, let's say, not helping a lot. At the same time, healthcare providers are also looking at finding solutions that are cost-minded and are also looking to make their workflows more efficient. And what we also see is that with the advent of new upcoming technologies for monitoring, that population is actually willing to take more charge of their own health in their own hands by using advanced technologies. So Philips is actually committed to improve people's life, and with this in mind, and also with the fact that what we see is the digital transformation is driving a growth in health data, and we expect in the coming years to have a tremendous growth by 2025, maybe more than 30% of growth per year. Technology solutions could come for the healthcare needs, could come actually from data and from artificial intelligence. And where do we want Philips to act? There are several pathways how we can bring our solutions. is one is support to the experts and to actually derive the most of the value of the caregivers and of the medical expertise, for example, by using support, decision supports. Another way is operational efficiency, and think about it simplifying workflows and giving more time to the caregiver to spend taking care of the patient. And another way again is by empowering people, by empowering us to have technologies that take care of ourselves and let's say support a healthier lifestyle. The presentation of today is on a use case related to healthcare, and it also tackles aspects of data exchange between hospitals, and it's actually having, let's say, as a core technology, human biometrics. Let me start with the use case. Obesity represents a large and also unfortunately increasing fraction in the population. So medical experts identify multiple risks for cardiometabolic disease that are related to obesity, such as cardiovascular and diabetes. So therefore, it is very important to analyze the health risks that are associated with excess of fat in the body. One of the concerns of the medical specialists is how the fat is distributed in the body. If you look at this picture, we have two situations: a metabolically unhealthy and a metabolically healthy situation. In the left picture, you clearly can see that the fat accumulation is particularly on the internal organs. This is what we call metabolically unhealthy. By choosing treatment and also healthy diet and also let's say a change in physical activity, we hope to bring the patient from the unhealthy situation to the metabolically healthy one. But it's very important that during the treatment we have techniques to monitor how the excess of fat is distributed in the body. So what is the clinical practice now? If we are using body mass index or other anthropomorphic indices, the advantage of such measures actually is very accessible, can be done quite frequently. However, the accuracy is rather low, and also a concern for the doctors is that the variability between clinics is also a big factor in let's say in judging these results. What is the alternative? Medical imaging. So you can use CT imaging to visualize the distribution of the fat, of the internal fat in the body. However, and this is actually very accurate method, the doctors can see a lot of detail. However, it is a costly method, cannot be done so frequently, and what is also a big concern is the unwanted exposure to the radiation for the patient. So clearly the medical experts are facing a dilemma. In 2018, we partnered in a European project called BodyPass. We partnered with, we engaged in a project that had as a goal to break the silos between data coming from healthcare domain and also bridge them with data coming from consumer goods domain. So we partner with technology partners, but also with two hospitals and also with consumer goods company. And the hospitals are Cliva from Valencia, and also from Milan. These hospitals have expertise in endocrinology and also oncology. So it's also important to realize that so basically for this project, the central use case was actually to find new metrics that could accurately link external body measures to the distribution of fat in the organs. Yes, and what I would also want to emphasize is that in doing that, actually, there was also an exchange of data, and together with our partners, we also have brought solutions in how to safely build models that also respect the privacy of the patient. We have a safe data exchange, and I will actually come back later to this point. So first of all, let's explain a bit what is parametric body model and how we can enable body metrics in healthcare. I will start with a map because and we all know it. It's the map of the Earth, and the question is what makes a map unique. So we can design the map, but actually parameterizing it enables to do a lot of applications. For example, localization, for example, navigation, like you see here. I tried to see how fast I can bike from Eindhoven to Maastricht. And not only that, but not only navigation, but also you are probably also aware of a lot of applications that are built around mapping, like transit services, promotion. Yes, so a lot of applications, digital applications that are now, let's say, built on top of existing maps. So, in analogy with the parameterization of the Earth, we can think also of the human body also in a parametric way by considering so in this representation, basically a human body is a collection of 3D vertices, and each of these vertices represents a unique location, a unique anatomical location on the body. So if I can think of two different bodies, for example, the shoulder or the left shoulder will always have the same index for both bodies, or as many bodies as they are, irrespectful to their shape. So this is what we mean of parameterization. So what does it allow us, or if we make the analogy, so we can draw arbitrary points, we can draw contours on the body, we can distinguish between symmetric definitions. We can do, for example, we can calculate surfaces of over certain areas and volumes, angles, and everything that you can imagine geometrically on the body. It is also important to realize that because of this parameterization, when we work with multiple data sites, in this case hospitals, we also, we can actually refer to the same type of data as measurement irrespectful to which site has been acquired the data. And this is actually, let's say, enabling later to share, let's say, model data or aggregated data, and still, let's say, talking about the same thing without needing to access the individual patient's data. What else can I do with this parametric body model? Because in a database you have, for example, also other parameters like demographic parameters together with positions of vertices. You can build up models, predictive models that use a set of parameters to predict the body. Of course, the more parameters are used, the higher the accuracy of the body avatar that you can expect. So every time that we add a new scan to the database, the scan is going to be registered to the same parameterization, And basically everything that we have derived or measured on one body applies also to, as a measured definition, it applies also to the new data point. Here I show an example of how we can model the age effect on, actually this is a rejuvenation effect, I would say, on a set of data. And what was actually interesting for our project is to make assessments inside the body. So the collaboration with the Body Path project allowed us to let's say, extend the model from outside the body to inside the body. With the acquisition of CT scans in both hospitals, we've been able to, let's say, use registration techniques and build up in the same way that we have the parametric body model for the external body, also for organ. And with this, actually, the doctors can define custom metrics of interest and propagate through their own database. Like you can see here the example of a customly defined contour on a liver. In essence, parametric body model enables definition of exact geometrical and non-geometrical measurements. When you have a database of scans which are registered to this parametric model, you can actually propagate measurements throughout the database, and therefore, together with non-geometrical measurements like fat concentration, you can build predicting models such as prediction of fat concentration starting from external body measurements and some demographic data. In essence, in this example, we built an information system where different partners can, let's say, can provide their data without, let's say, accessing individual data. And we have built actually a system that allows querying of data from this system in an aggregated way, only by, for example, querying model coefficients or averages of data. And let's say we have made a proof of concept of how you can exchange data in a safe way without altering the privacy of individual patients' data. And then to, let's say, have a vision for the future, you can imagine how, by using such models, one can get a treatment and can, let's say, monitor throughout the treatment not only how he physically looks like by applying the treatment, but also what the effects on the health and on the fat distributions are at the end. So this concludes my presentation, and I would also like to use this opportunity to thank to our collaborating hospitals and our partners, as well as to our Philips research program for supporting us, and most of it to a multidisciplinary team that combines competencies in data science, clinical science, and also platform development. And I wouldn't know how we are with time. We can go to questions, or I can share still share a few thoughts about working with data science.
We have some more. I think we can, if you use 3 minutes, we have then still 5 minutes for questions. So I think you can go ahead, and then we can ask questions.
Okay. So yeah. So I will use. Thank you. Then I will use a few minutes to share some personal drives in data science. So I think I have already gave a short introduction about myself, and Mirela also did it. I'm coming from Romania, studied north of Romania, and later came to the Netherlands, where I did both PhD in Amsterdam and worked at Philips Research since 2003. And I would like actually to end the presentation with a food for thought, inspired by famous, perhaps most famous sculptor, Romanian sculptor, Constantin Brâncuș, who referred to his sculpture called Bird as not being a bird, but is the flight. And it's not about the exterior of a work, it's about the idea and about the essence of things. And I think with data science, there is data, but in the end, there is the knowledge and the insights that we want to derive from the data. And this is, let's say, something that we can take along and think about it, perhaps also in the second part of the event. Thank you.
Thank you for watching this WIS Conference 2022 video from Maastricht. And you're welcome to watch more conference videos from WIS worldwide on YouTube. Please keep watching.